Happy New Year.
Okay, so we are fixing to cover 6.1. Next Thursday and Friday, not this Thursday and Friday, but next Thursday and Friday, you should have a test on 6.1 and 6.2, which is law signs and law cosines. We are going to be doing lots of worksheets, and then you'll have that 100-point test. People, you better learn log signs and log cosines. You will not pass this 6 weeks if you do not. If you go, well, I don't really care. I'm tired of trig. I'm just going to wait till we get to college algebra. You will flunk the first 6 weeks of the semester. Okay? So learn your log signs and log cosines. So this is what I asked you to get from the table. You can just put it aside. I asked you to get 1 blue, 1 pink, 1 black, and 2 whites. Yours are longer. Don't mess with them. Okay? And then a note card. Okay? So put it all to the side and let's, what?
1 white or 2 white?
2 whites. You need 2 whites. Don't bump the camera. If you need to go get 2 whites, get you 2 whites. We're fixing to start taking notes. Okay, so this is, I'm going to back this up just a little bit. I may have to refocus, but yeah. All right, so this is 6.1. 6.1 is going to be law of signs. 6.2 is going to be law of cosines. So 6.1, law of signs. Law of signs. All right, so why do we have law of signs and law of cosines? Well, this is why. You use law of signs and law of cosines to solve oblique triangles. Okay, so we've been using trig functions. Does everybody agree? And we've been solving triangles and doing all kinds of stuff with it. What kind of triangle does it have to be to use a trig function?
Right.
A right triangle. Are all the triangles that deal with real life application right triangles? No. So that's why we have law of signs and law of cosines. Any triangle that does not have a right angle in it is called an oblique triangle. All right, so did you hear me? Any triangle that does not have a right angle in it, does not have a right angle in it is called an oblique triangle. So let's write that down. Oblique triangle. It has no what?
Right.
Right angle. All right? Now, this is what you have to know to be able to solve an oblique triangle. You must know 3 things. 3 things. Now, listen to me. Could it be 3 angles?
Yes.
If I knew 3 angles of a triangle, would I know everything that I need to know about that triangle?
No.
Yes.
No.
Yes.
Let's see. What if I tell you that this angle right here is congruent to this angle, and this angle is congruent to this angle, and this angle right here is congruent to this angle right here?
That don't tell us anything.
That doesn't tell you anything, does it? Because do you know how big that triangle is? No, you have no earthly idea how big it is. Does anybody know what these 2 triangles are said to be?
Equal.
Similar. Very good. There's the symbol for similar, all right? And you learned this in geometry. So similar triangles are triangles whose angles are congruent, but the sides are what?
Different.
They're proportional, okay? They are proportional. So here's what happens. If you only know 3 angles in a triangle, you can't tell, cannot tell the shape of the triangle,
Yeah.
but you can't tell how big it is. It can be teeny tiny like the top of a pinhead, or it can be gigantic like covering the oceans, all right? So not 3 sides. You have to know 3 things, but you must know the measure of one side and any 2 other parts. Okay? One side and any 2 other parts. So that one side is going to determine the size of your triangle. The angles are going to determine his shape, but the sides are going to determine how big it is. All right? So, we're going to have, now look, here's what I'm going to do. We're going to talk about 4 cases. Okay? I'm going to leave some room over here on the left of my paper because I'm going to come back and write just a little bit of something over here. So when I do my 4 cases, I'm going to start over here. Okay? All right, so these are ways that you can find measurements of angles. These are actually ways that you proved triangles were congruent in geometry. Okay, so I'm going to make my little disclaimer before we get to it, and my disclaimer is I'm going to say a bad word. Okay, so there it is. I warned you, all right? So I think you're all old enough, you'll be okay. All right, I don't think I'll scar anybody, but anyway. So here we go. Do you remember in geometry when you proved triangles were congruent, and one of them was angle, angle, side? Remember that? Okay. Or you could use angle, side, angle. Now both of these use 2 angles and 1 side. Do you agree?
Do we not speak of the other one?
2 angles and 1 side. Now, hang on just a second. All right, so I'm going to talk about this triangle right here because I want to know if you understand what these letters mean and that the order of the letters is important. Do you all agree with that? Okay, so I'm going to call this, I'm going to use numbers and letters just so that you can show me if you know what I'm talking about. So I'm going to call this angle 1, this angle 2, and this angle 3. Are you with me? I'm going to call this side A, this side B, and this side C. Okay? So give me an example of angle, angle, side using that drawing right there.
1, 2B.
Very good. Angle, angle, side.
3,
It's
1,
2 angles and a non-included side. Angle, angle, side. 1, 2B. What's another one?
3, 1A.
3, 1A.
2, 3A.
What?
2, 3A.
2, 3A. 3, 2A. Yes?
Yeah.
3,
What's
2C.
another one?
2, 1C.
2, 1C. Does everybody understand what I'm saying? Yes?
Can you
Okay.
have, wait, can you have 3, 2B?
3, 2B? No. That's not angle, angle, side. That's what?
Angle, side.
Angle, side,
Okay.
angle. That's this guy right here. It is 2 angles and a side, all right? But it is the included side. So that would be 3B2. 2 angles and the included side.
Like
Okay?
1, 2A.
Give me another example of angle, side, angle.
1C3.
1C3.
3C1.
Angle, side, angle. Okay? What about this one? 1A2.
1A2.
Angle, side, angle. Are you all with me?
Okay.
Okay? All right, here's number 2. Angle, side, side. Oh no. Could you use this one in geometry?
No.
No. It spells ass, people. You can't say that in the 10th grade or the 9th grade, okay? So, but now we're big kids, okay? Now listen to
He
me.
told us that we would be able to use it.
Use
in
this
here.
later on. Now y'all listen to me. Here's the bad part about it, okay? This one right here, this is the most difficult one. And if you're not careful, that's what he'll make out of you, okay? So you're gonna, whenever this one comes up, you need to go, uh-oh, wait a minute, this is a bad one. I need to really pay attention to what I'm doing, okay? So he is 2 sides and an angle opposite one of this one side. Okay? 2 sides and an angle opposite one of those sides. Okay, so I'm going to go go back up here and I'm gonna show you what it's gonna look like. And instead of using these numbers, I'm gonna use the capital
Sheet
letters to name the angles, okay? Tell me what the name of this angle is right here.
Capital A.
Capital what?
C.
B.
B.
Thank you.
Oh, it's
B is
opposite.
opposite him, so this is capital B. What about this guy right here?
C.
C. What about this guy right here?
A.
A. Okay? So if you're talking about angle side side, all right, watch what's going to happen. If I use this angle and these two sides, that would be angle B and side A and side B.
Bad.
Okay? Let me show you another one. What if I'm talking about this angle and these two sides? That would be angle C and side B and C. Every time, what are you seeing?
Cac.
A pair. Do y'all understand what I mean when I say a pair?
Yeah.
An angle in his side will be in here and another side. All right? So we're going to write that. It must have a pair. And when I say a pair, I mean an angle. An angle and his side. Okay, so you'll either have a big A and a little a big B and a little b, a big C and a little c. Does everybody understand that? Is it going to be hard to spot this guy right here?
Yes.
I just told you, people, what are you going to have?
Pair.
A pair and another side. It is not hard to spot. A pair and another side. A big A and a little a, and then another side.
Oh.
Okay? All right.
Bless you.
This is the bad one. We're gonna talk. That's what we're using all our papers for. Okay. So here's the next one. The next one is you could do side, side, side. Obviously, that's 3 sides. Okay. He's not bad. Here's the next one. Side, angle, side. So this is going to be 2 sides. And what about my angle?
In between.
Yeah. And it's called an included and included angle. Because he's included in between the sides. Okay, I'm going to shut this door.
Especially for saying bad words and stuff.
Okay. All right. Now, here's something that you need to know. These 2 right here, that's when you're going to use law of signs. These 2 right here, this is when you're going to use law of cosines.
Wait. Is that law or signs or law?
Law of. Sorry. So picky. Like it's just missing a little stick. All right. So law of signs, law of cosines. Now y'all listen to me. You're gonna like law of signs. Law of cosines, not so much. Okay? But you don't really have to know the difference in these because you're going to say, well, I'm going to use law of signs, and then you're going to go, uh-oh, I can't use law of signs. And what does that mean?
Law of cosine.
Law of cosines is what you're going to have to use, okay? All right, but we're going to learn it all. It's not going to be bad. Okay, so here's the next thing I want you to do. We're going to write the law of signs on our paper, and then we're going to put it on our note card, okay? We're going to write the law of signs on our paper, and then we're going to put it on our note card. So, law of signs. Here's law of signs. It can be written 2 different ways. So I'm going to write it both ways. It's very easy. You won't even need your note card for it, but you'll have it just in case you get scared. All right? But it's side A is to the sine of angle A, as side B is to the sine of angle B, as, guess what the last one is?
C.
Side C is to the sine of what?
Angle B.
C.
Stop. Remember what I said about being
No, I forgot
side
which one
C,
we were on.
angle C.
I was writing B as you were
Oh, okay.
talking about C.
Okay.
So.
So, side A is to the sine of A, as side B is to the sine of B, as side C is to the sine of C. All right? Or, you can just flip it. I don't know. I don't ever use this one over here, but you could if it made you happy, I guess. The sine of A is to the side of A, as the sine of B is to the side of B, as the sine of C is to the side C. Okay, now obviously you are not going to use 3 fractions set equal to each other. You're just gonna use 2, and it'll look like a proportion, okay? How do you solve a proportion? Cross multiply. So we're gonna work one of those, okay? Are you ready? Now, let me make this plain and clear. In order to use law of signs, you must have a pair. All right? So that is any angle and his side. Okay? Like angle A and side A, angle B and side B, angle C and side C. If you don't have a pair, you can't use law of
Wait,
signs.
so say you have sine of the big A, right? And then you
Mhm.
have the little a,
Mhm.
and then you're gonna have one of the other.
Then you're gonna have
previous-
one of the other ones,
And then
and
you
so
gotta
then I
solve for
combine them
X.
with, that's exactly right, we'll solve for everything else.
Gotcha.
Okay? All right, so here we go. Example 1. Everybody okay? So, oh, we're gonna write this on our card. I'm sorry, I forgot. So there it is. Put it on your card right now.
How much are we gonna fit on this one?
I would put it just like I did, because that'll leave you with plenty of room to write whatever we need to write. Law of cosines will probably take up the back of your card. It doesn't have to, but we'll put everything else on the front. There's 2 other things that'll be on the front, and then on the back we'll put law of cosines, and it's a lot more involved.
Oh, darn. You keep on switching up the sign. At first you were using sign with an E. Then all of a sudden, no. Crazy.
I didn't want people to think it was the law of sin. We're not studying about sin. We're studying about asa and ass. That's what we're talking about today. Okay? All right, everybody ready now? You got it on your card? Yes?
Yes.
Okay, so let's do our example. So this would be a kind of problem that you would have. I'm gonna tell you, now how many things do I have to know?
3.
And one of them has to be a
Measure of size.
side. One has to be a side. You have to have one side. The other 2 can be anything in the world, okay? So I'm gonna tell you that angle C is equal to 102.3 degrees. I'm gonna tell you that angle B is equal to 28.7 degrees. And that side B is 27.4 feet. Okay?
Is this how it's gonna be, or are they gonna give us triangles?
They could do it this way, or they could write it on a picture. But we're gonna draw a picture anyway, okay? Because a picture is worth 1,000 words. All right, so you're gonna find all, this is what your directions say. Find all missing parts.
So we need to find all sides and all angles?
That's exactly right. Now y'all look, we've done things like this before, haven't we? We just did it with a right triangle. Obviously, this is not going to be a right triangle, okay? What kind of triangle is it? Oblique, okay? So that means that's why we're using law of sines and law of cosines. So tell me what the missing parts are. What's the missing angle?
Well, we have
Angle A, so we're gonna find him. What about a missing side?
A and C.
Side A and side C. Very good. Okay, so I'm gonna take my direction from them. They rounded off to one place, so I'm gonna round off to one place if necessary. Okay, I am gonna draw my picture, and I'm gonna tell you this. When you draw your picture, I would make sure and draw to scale. Now, does that mean that I'm going to get out my protractor and everything? No, that's not what that means. It just means that if my angle is 102.3, he's what kind of an angle?
Big.
Up to you.
Obtuse angle, okay? He's bigger than 90. So I'm gonna make him look that way, all right? So This is bigger than 90, okay? This is angle C. He's 102.3. All right? And then I'm gonna go up here, I'm gonna do angle B, which is gonna be very small. He's 28 point something. 28.7. And then this must be angle A down here. I'm gonna label my sides. Are you with me? Tell me what side this is. A. Right here. And B. Okay, I know what B is. He's 27.4 feet. This unit of measure is determining the length and the unit of measure that I will use on the other two sides. Okay, now I already told you in order to use the law of sines, what do you have to have?
One side.
And 200.
No, to
In a
use the
pair.
law of
A pair.
sines, you have to have a pair, okay? You have to have a pair to use the law of sines. Do I have a pair?
We got
Yes.
side B and angle B.
Very good, then that's the pair that I'm going to use, okay? So, is it easy to find angle A right now?
Yes.
Yeah. What do you know about all the angles in a triangle?
180.
Okay, so I can find angle A really easy. I can just say 180 minus 102.3 minus 28.7. Okay? You're probably gonna need a calculator. Alright? So if you don't have a calculator on your desk, go and get one, and I'll do this in my calculator for you, and then you'll be back. Watch, be careful, don't bump that desk. Okay, so here it is right here. 180 minus 102.3 minus 28.7, 49 degrees. So I'm gonna go ahead and fill that in. 49 degrees, that's my angle. All right? Anybody got a question? Nope? Okay, so here's the way you use law of sines. Law of sines. I'm gonna use my pair. I normally put the side on the top and the angle on the bottom, but you could flip it because you saw that the formula goes either way. Okay, so I'm gonna say 27.4 is to the sine of what?
Opposite over
Yeah.
hypotenuse.
No, stop. The sine of, what's his angle? 28.7. Are you with me? This side is to the sine of his angle. B is to the sine of B. As, let's find C first. C is to the sine of angle C. What's angle C?
We don't know.
Yes, you do.
Oh wait, yeah we do.
102.3. Okay? Do you see how nice a picture is? I love the picture because I just go, this angle is to the sine of this side, is this angle, pardon me. This side is to the sine of this angle, is this side is to the sine of this angle.
I just gonna keep.
Okay? Now, I'm gonna do this one time and then I'm not ever gonna do it again. Okay? So we're gonna cross multiply. So I'm gonna get the sine of 28.7 times C is equal to 27.4 times the sine of 102.3. Now, what do I do to solve for C? Yeah, divide by the sine of 28.7. These cancel out. C is equal to. Are you with me? All I did was cross multiply.
I'm not there.
I cross multiplied right here and got the sine of 28.7 times C. I cross multiplied right here and got 27.4 times the sine of 102.3. And then I'm solving, this is my variable, people, right here. This is my variable, the guy I'm trying to get all by himself. So how do you get rid of this? Well, they multiplied, so we what? Divide. These cancel out, and C is equal to. And I'll put this in my calculator. okay? It's hard to see my calculator, I really need, especially since we covered that light up there, I really need one of those, electric ones, but whatever. So, tell me what, or backlit ones, or whatever y'all call those. Tell me what I'm gonna do very first thing.
Multiply.
Oh, put your calculator in.
Yeah, make sure, go to your mode and make sure you're in degrees, okay? Make sure you're in degrees. So then, after we do that, then yes, we're doing what Sean said. We're going 27.4 times the sine of 102.3, close the parentheses, divided by the sine of 28.7. And you can close them at the end or not, your calculator doesn't care about being proper. And so my answer is what?
55.7. No, 0.7.
Yeah, we're just gonna round it off one, so 55.7 feet. Anybody got a question? Is everybody okay? All right, so I'm gonna show you why I'm not gonna write this anymore, okay? Look what you're always, y'all, this is what you're always going to do. Okay, think about in this X. You're gonna multiply the two that you know, and you're always gonna divide by the guy that's by himself. That's the way it always is, okay? So you're gonna multiply the two that you know, and you're gonna divide by the guy that goes with the variable. So I'm just gonna write this down. I'm just gonna write C is equal to, and I'll write this down, okay? But I'm not writing all that mess. So let's find another one. Who do we lack?
A.
A. Hey, could I use the Pythagorean theorem and find A?
No.
Why not?
Oh, it's not right.
That's right, it's not a right triangle. So every year I get a kid that's like, oh, I don't need to do that again. I'm gonna use the Pythagorean theorem. Like, no, buddy, okay, it's not a right triangle. It doesn't hold true for obliques. Okay, so somebody set me up my proportion that solves for A.
27.4 over sine of 28.7
Perfect.
equals A over sine 49.
Okay, so this is what he did. He said this side is to the sine of his angle, as this side is to the sine of his angle, and we found it, just didn't write it in there. So the sine of 49. All right, so when I look for A, he's going to be, the two that I know go on top, 27.4 times the sine of 49 over the guy that's the odd man out, okay? He's like the third wheel on the J, sine of 28.7. So we're gonna do it in our calculators. 27.4 times the sine of 49. Don't forget to close those parentheses or it'll keep taking the sine through the rest of the problem and then it'll be wrong. Divided by the sine of 28.7. Is that what y'all got? 43.1?
Yes.
43.1?
Mhm.
Yeah, I got that.
All right, anybody got a question? No questions? Okay, so here's what we're gonna do. It's gonna take probably, what time's the bell ring? 50? Ooh, it'll probably take the rest of the class to do this, okay? But we're fixing to talk about this little guy right here, okay? So this guy, he's called the ambiguous case, okay? He is called the ambiguous case. Do y'all know what the word ambiguous means?
Mystery.
Yeah, more than one meaning, okay? It means it can have, do you know how sometimes you can say something and it can have more than one meaning?
Wait, so I can call somebody and, wait, what is it called again? Ambiguous what? What is that one?
This is an ambiguous, it's called the ambiguous case is what it's
So
called.
would be an ambiguous case.
No, Colton,
Okay.
okay? So, now listen to me. How are you going to know it's the ambiguous case?
Because it says that word.
No, because it has, yes, what? A pair and another side, okay? Not a pair and another angle, that's not ambiguous. Do you understand? It has a pair and another side. That's going to be the ambiguous case. All right, so put your notes aside for a second. All right, put your notes aside for a second, and we are fixing to, y'all listen to me. This is what we're fixing to write down. Do you see this chart right here?
Yes.
The ambiguous case. This chart is fixing to go in our notes and on our note card. All right, but I'm going to explain to you why. You're going to know what all the answers are. We're not going to just copy the card down. All right, so first of all, there could be two things. You can have an acute angle or an obtuse, but we're only going to talk about the acute one. Okay? So take the pink piece of paper, and that's going to be the base of my triangle. You're going to take the blue piece of paper, and you're going to make an acute angle. Now, this angle is my given angle. Can I change it?
No.
No. This blue is a given side. Can I change it?
No.
The other side is going to come from your white piece of paper, okay? It's going to come from your white piece of paper. So I'm going to, I'll tell you what I want you to do with it, all right? Now, this black little piece of paper right here, we're just using him for a reference, okay? We're just using him for a reference. So I'm just going to tell you he is not part of my triangle, but what is he measuring of my triangle?
Your right angle.
It's height. That's exactly right. It's its height. So you're going to put it from this angle up here straight down, perpendicular to the base. And all he's doing, he's just a reference for me. Because I'm going to say, tear me off a piece of paper that is blah. Okay? So here's the first one. The first one is, I want you to form a side A out of the white paper, and I want it to be shorter than the height. So I want you to take a piece of paper, okay, and I want you to make it shorter than the height. Tear off a little piece that's short. Look, tear off a little piece, I don't care how much shorter, that's shorter than the height. Are you with me? I'm going to make my angle a little bit bigger because I already got my papers torn. So, you're good. Don't worry about it. You're tearing your papers now. Okay, so is this paper shorter than my height? So put this paper up here. Now, obviously, this is, look, you can't see what I'm pointing at. This is angle A right here. And this is side A. This is side B. Angle A, side A, that's my pair. And side B, my other side. Angle, side, side. Angle, side, side. You with me? How many, put it up here where it belongs. How many triangles can you make?
Oh, I can't make one.
Can you make a triangle?
No.
Y'all, you can't make a triangle. This guy does not touch. The shortest distance from here to here is the height. And if he's shorter than that, he ain't making a triangle. Okay? So if you make this side right here shorter than that height, how many triangles can you make?
None.
0. Very good. Okay, so now look what I want you to do. Put that piece aside. We don't need it anymore. Okay? And don't throw them on the floor. I had to go and pick them all up this morning. That was crazy. Okay, I'm not your mama. Okay, so now I want you to form a side A that's the same length as the height. Okay? So now I want you to tear me off one that's the same length as the height.
Got it.
Okay? I want you to put it on there and don't shout the answer out, but I want you to see how many triangles you can make. Don't shout the answer out. Tear me a side A that is the same length as the height. How many triangles did you make?
None.
One. It's right there on top of the height. Do you agree?
Oh, I mean,
Okay?
yeah, but
I mean, what?
I keep forgetting this isn't a real plane.
No, the height is not really a side, guys. The height is just something that we're using to measure stuff by.
yeah, no, that's why I
Okay?
didn't think I could.
So
make
does
it.
everybody agree that you can only make one triangle? So do you understand ambiguous? How many answers have we gotten so far?
One.
2. You got 0 and you got 1.
No.
Okay? Now tell me this. Tear me off another piece. I want you to make a side that's longer than side B. I want it to be longer than side B. The blue is B. I want you to make me a piece that's longer than side B. B is the blue one. Okay? Longer than side B. And then I want you to triangles you can make? Don't say the answer out loud. Longer than side B. Here's mine. He's longer than side B. How many triangles?
A bunch. No, you can't make infinity because it only goes so far.
I can only make one.
No, because if you move it, you can make another one though.
It's this long. It has to go from this vertex to this vertex.
Oh, whoa.
How can you move it? If you move
Well,
it
you
out
pick up
this
the
way,
piece
he
of
won't
paper.
touch. If you move it up that way, you made him shorter.
Well,
How many triangles does it make, guys?
One.
One triangle. He is this length. You can't change. The pink is the only guy that you can change his length. The blue is a given length and the white is a given length. Once you tear it, you decided its length and you can't change it.
I know, but say, since yours isn't touching the edge of the pink, you can move it up a little bit, and then you can move it down. That's different triangles.
Okay, that's because mine is really fat. Okay? Because I tried spaghetti one year and what happened to it?
People hate it.
No, they kept rolling off the desk and we were getting frustrated. So then I did linguine, all right, but then the mouse got into it. So now I just do linguine, all right? So,
Ratatouille.
all right, so here we go. So listen to me, what answers? We got 0, 1, and 1. Okay, now here's the last one. I want you to make a side that's longer than the height, but shorter than B.
Oh.
Longer than the height, but shorter than the blue.
Good.
Longer than the height, but he has to be shorter than blue.
Boo.
Boo. Huh?
Whoa.
Boo.
Hey.
That was our guinea pig's name, Boo.
Ah.
Okay.
Yeah. Yeah, that my husband said, that's the biggest dang hamster I've ever seen.
It was a good thing.
Yeah. No, don't tell him, children,
It
don't
was
tell him.
G-force.
He only said we could get a guinea pig, a hamster. All right, so are you ready? Anybody know how many triangles you can make?
One.
Watch this. Is that what you made?
Yeah.
Now watch this.
Oh, you can do that.
Oh, how many did I make?
2.
2. Look at the possible answers, 0, 1, or 2 triangles, depending on the length of this side that's opposite that angle, okay? So 0, 1, or 2. Now watch this. I'm going to see if I can find the other piece
So
that's
what are you trying
exactly.
to say?
Yeah, I don't
I don't get your point on this.
I'm saying that you can make
0, 1, or 2.
0, 1, or 2 triangles depending on the length of the side. That's why it's called the ambiguous case.
'Cause you can
Okay,
make
now
zero
watch,
and two.
watch this. I want you to look at this for a second, okay? So, does everybody see this is one of my triangles? Do you see it? Okay, now I'm not gonna pick that piece up. This is the other one. It goes like this. Do you see it? Disregard these two right here. All right? I want to know if there is a relationship between this angle right here. Come on, Ian. Well, it was, but it won't write. I want to know if there's a relationship between this angle right here and this angle right here.
They should make 90.
180.
Supplementary. Okay?
Oh, yeah, 180. My
Supplementary.
bad.
Not 90, but 180.
Yeah, yeah.
Okay, so let me show you why they make that, okay? So pretend that you're only looking at the pink and white triangle, this one right here, okay? What do you know about these two sides?
Equal.
They're equal, y'all. They are the same piece of paper, supposedly. All right? So they are the same. So if these two sides are the same, what do you know about these two angles?
Same.
So this angle is congruent to this angle, right? Now look at these two. They make, anybody know what that's called? A linear pair. That's a linear pair. It forms a straight line, they have a common side.
Oh,
and
because it's
common
a pair
vertex.
that makes a line.
And so that's exactly right. So that means they're supplementary. Okay? That's going to come back into play later on when we start solving problems with the ambiguous case.
Because you know with supplementary, since it's an S, you put a 1 in front of it and then connect it and it's an 8.
Yes, that's the way I learned it. Okay, so here's what I want you to do. Ooh, I'll have to clean that up. Spit on it later. All right, I want you to write this down in your notes, and then it'll be your responsibility to put it on your card. Okay? All you're doing is this.
Just the triangle part?
Yes.
We're gonna go.
We did not do an obtuse one. We didn't look at it because really it's very simple. You either have a side that is shorter than this other side, in which case you can't make any triangles, or you have one that's longer than that other side, in which case you can only make one. Okay? So it's the ambiguous case. It says do the exercise first. You don't have to write that. That's just for me. Those are my notes. We did the exercise with the paper.
Wait, so we have to,
I would put it in my notes and then somehow you're gonna, no, don't do it on the back. Do it on the front, but, just try to make it
Is
fit.
that the last thing we have to have on the front?
No, there's gonna be two other things on there, or one, at least one other thing. I'll just say there's one other thing on there. So I wouldn't take up all the rest of my card. Okay, I'm gonna go stop the video.